Welcome to the first episode of Visual Data Structure, a series related to data structures in programming. Today we'll talk about the basics of the computer memory and how it is used to store data structures. This is a fundamental topic that a lot of online classes generally skip or handle it very superficially. With today's video, you'll get a better understanding of the basic unit of a data structure, a variable, and we'll see how it gets stored in the computer memory. With these understandings, you will then be able to move to more advanced topics such as arrays or lists. So let's get started. Variables are incredibly important in computer science. They allow us to store information in the computer memory. In addition, once that information is stored, we can modify it and read it. Variables can store numbers, characters, strings, and much more. Let's see how they work with an example. Today, we're going to the grocery store, and we would like to have a list of things we need to buy. Variables are great for this. We can use one variable for each element that we're planning to buy. Imagine this grid to be your computer memory. We generally refer to this type of computer memory as RAM, Random Access Memory. The idea is that the computer can freely write and overwrite data on it. Each space represents a unit of memory. Each of these cells has a specific address. In this case, we can define the address as the number of cells on the X coordinate and on the Y coordinate. For example, what you're seeing now is the address located on the fourth position both on the X and the Y axis. We want to store what we want to buy in this computer memory, and for each item we'll use a different variable. A variable has a type, a name, and a value. The type represents what we're storing in the variable. In our case, since we're storing grocery items, the type of the variable will be a string. You can then choose the names that better suit what you're storing. In our case, we'll call our variable item 1, item 2, item 3, and so on. Finally, each of these variables will have as a value the name of a grocery item. We're going to use Java as a programming language, but the idea is very similar for other programming languages too. Every time we store a variable, we occupy one cell of this memory. Imagine we create a variable and we call it item 1, and we set it to be equal to the word milk. Now, one of these cells will contain the word milk, and the item 1 variable will know the address in memory for this value. You can think of the variable as a link to a cell in memory. Every time we create a new variable, the computer will decide where to store it. So if milk ends up here, item 1 will be linked to the address 4x4, which is the coordinate of the cell. If milk ends up here instead, the variable item 1 will contain the address 2x3. So when we need to read what's the value of item 1, the computer will know where to find it. Similarly, if we want to update the value of item 1, we'll get the location and change the value of it. Let's say that we found out that we still have some milk left at home, but we need some cereals. We can change the value of our variable item 1 to be cereal. We can then create item 2 for yogurt, item 3 for apples, and we keep adding all the elements we need to buy at the grocery store. Now, once we'll go to the grocery store, we can read the variables of item 1, item 2, and all the items that we created in our program to see what are the corresponding items that we need to buy. As you can imagine, this is a bit inconvenient, since you have to remember the name of all the variables that contain grocery items. Luckily, there is a better way to handle this case, and you can see it on the second video of Visual Data Structure that deals with arrays. One final note is that every time we use a cell in memory, we're reducing the amount of free space the computer has. If this amount becomes very small, the computer will start to slow down and eventually will crash. This is why it's important to make sure that variables get removed when they're no longer being used. In certain languages, this is something that the developer has to do, while in other programming languages, this is handled by the environment and the developer doesn't have to worry about it. The model we just saw is a pretty accurate representation of what happens when we store variables, but it's important to mention that there are a bunch of details that the operating system handles for us. For example, not all the variables occupy a single cell. In fact, based on the architecture of the machine we're using and the programming language, the same variable can occupy a different amount of space. I hope you enjoyed this first video of visual data structure. I'll suggest you to watch the second one that deals with arrays. And if you like this video, please subscribe to the channel.